look and get the window. See who we got. We got Alon, welcome. Alon has been to quite a few before. Welcome again. Got Eugene's. I'm sure recognize those names. Alexi, I think so.
I recognize almost everyone.
You and everybody. Everybody knows you, and you know everybody.
Welcome, Mark, by the way.
I'm in my hospital room, as usual. Where is everybody? You can let us know in the chat. Just change it so it says to everybody. So I'm here in London. Alexi, Amsterdam?
Yep.
Amsterdam this time. Jerry, hi Jerry. So Jerry maybe has watched someone's afterwards. Cool. Glad you're here. It's much more fun when it's live. We got Jakarta, we got Iceland, we got Bengaluru, we've got Dallas. Wow, we got covered across the world already. So we'll give people a few minutes to join. And yeah, we can see Tyler has posted the YouTube link. If you want to share that with anybody for afterwards, you can share that.
Welcome, Todd, as usual. Nice to see you again. Welcome, Stefan. Welcome, Robert Schulze. Nice to see you live on the call. Navesh, Michael, Jerry, Goran, Himanshu, Eugene, and another Eugene. Welcome and welcome. Welcome, Don Spencer. What is the most unusual location?
So far, I don't know which one. Yeah, I mean, they're all quite big cities, I guess, so far. We've got Toronto, two people in Toronto. I know one person in Toronto. Toronto's there twice, though.
Is
It's
Toronto
just,
anyhow unusual? I don't know.
no, maybe not. Toronto, or is it South Africa, maybe the most south?
Maybe.
Jakarta, the
Anyone,
most east?
anyone from Australia?
Yeah, what time is in Australia? It's like 2 a.m. or something. That'll be good commitment to the call. Cool. I guess we've done three minutes or so. So should we get started then?
Let's start.
Let's do it.
We have a lot of content, a lot of new features. So this is ClickHouse release 25.7, ClickHouse summer release or mid-summer release. And we will have most of the time for the new features, just a bit for a guest presentation, and if we will be happy, we will have a short Q&A. We have 27 new features, 26 performance optimizations, and 98 bug fixes. So what do we have? Let's start with something small and nice. Some nice additions to ClickHouse in this summer. And the first one is a new system table, system.formats. This is contributed by me. And guess what? It will show you the information about input and output formats in ClickHouse. So let's take a look. I will run ClickHouse local here in my terminal, and I will run it as simple as ch. It is available as short alias ch. And let me ask you the first question. How many data formats do we have in ClickHouse? I will copy paste a query, but first I will give you a chance to answer. And the first
Man, there's a
answer,
lot. There's way more than I like. I'm gonna say, I don't know, 75. Robert says
okay,
50.
75, 50. Who is like believe in ClickHouse the most?
Goran says 46. Come on, somebody needs to be higher than 75. I'm always the pessimistic one. We can't have me being highest.
Maybe over 1,000?
And
No.
Mari says
That
89.
was,
Michael 90, very clever.
yeah. I will ask you a lot of questions today. And the one who will answer the most questions will have a chance to get this t-shirt. Not exactly this t-shirt, but a similar one. Okay,
Joey,
so
this
let's
is
take a look. 105.
105. So who wins? I think Michael maybe is the closest. I know Michael and Javier are both the closest. They're 15 apart on either side.
Okay, interesting. Why do you have so many data formats? Why do so many data formats even exist? Let's take a look. If we look at just a single record, like here, we can see a lot of properties like, is the format suitable for input or is it only for output? Does it support parallel parsing, parallel formatting? Does it support random access, schema inference, etc., etc.? And let's take a look how many input formats do we have. Something that ClickHouse can read. It can read TSV, it can read CSV, it can read JSON, Parquet, protobuf. It can write XML, if you didn't know, but it cannot read XML as of today. So we have 73 input formats. And we have 90 output formats. Almost every format is suitable for output. If we filter formats that are supported both ways, input and output, it will be just 58, which is still quite a lot. And interesting, which formats can be used only for input, but not for output. Maybe you can name at least one of them. Mark, any ideas?
Input but not output.
Something that you can read, but you cannot write.
Huh. Can't think of anything. Damn it, I'm sure somebody else is going to do better than me on this one.
That is interesting because these formats should be quite special. They should be specific for the purpose. I
There
will give
must
it
be some, are there some like some variations of JSON that you can only read and can't write?
maybe, but I'm not sure. There are quite a few formats of this type. Let's take a look.
Okay.
There is one format named one.
Oh, that's my favorite one. One.
And there is also another format named Parquet metadata. So you get a Parquet file, you can read metadata from it, but writing metadata back does not make sense. You just write back a regular Parquet format or MySQL dump. We cannot write MySQL dump apparently, but we can read it.
There's two JSON ones. JSON as string and JSON as object. JSON as object reads into the JSON type, right? So I guess it doesn't make so much sense on the way out.
Yeah. Then there is also interesting format named regexp. It will parse anything by regular expression. And that's basically it. Another question. We have so many formats, but what formats do we miss in ClickHouse? What do you miss? What do you want me or anyone else to implement and make available for everyone?
Robert says hash.
Hash, do you mean just calculate a hash of all the results set? Okay, we will
Yes.
do it. Okay, let's go to the next.
Yeah, Robert, you've abruptly ended that section.
One is enough. We will add the hash format and it will be okay. At least we have 100 and more formats. Another feature is about financial functions. Maybe we can say accounting functions. to make it sound even more boring. And we have 4 new functions. Financial internal rate of return, financial internal rate of return extended, financial net present value, and financial net present value extended. And there are abbreviations, and we decided not to use these abbreviations inside ClickHouse because we are not accountant. We don't like these cryptic abbreviations. But internal rate of return is also known as IRR. Net present value is known as NPV. And let's try to figure out what does it mean and why do we have this function in these functions in the new release. Maybe it will be boring, maybe it will be interesting. I will take a look at the first function, internal rate of return. It takes an array of integers or floating point values with some amounts of money. And if the element is negative, it is considered like your investment. So this means that you invested $1 or one whatever else. And positive values are considered as returns. So you invested $1, and after a while, after some period of time, you get $1 as a return. The question is, what will be the IRR, internal rate of return? I think it should be 0 because we just returned our money back. And yes, it is very close to 0. Very close because this function does something special. Let's take a look. What if we just check the sanity of this function? We will invest $1, then we will get 0, again 0, again 0, and after a while we will get our investment back. And the result is still very close to 0. If I will do rounding like this, it will show exactly 0. Now let's try to guess the physical sense, some intuition behind this function. And again, we will invest $1, then we will get back 10%, 10%, again 10%, and after a while we will get back 10% plus our principal $1. And it returns 10%. So it works as expected. Pretty nice. Now let's take a look at another example. We will get the amount of our investment 100% back, and then again 100%. What do you think the rate of return will be? And again, let me ask Mark.
Oh man, I'm going to be so bad at this. So what we did, we spent 1 and we got back 2.
Yeah.
So it should be 100%. It's going to be wrong.
Actually, no, it is not 100%, it is 61.8%. And another question, what it is? What is it? What is it? 61.88%.
I have no idea. I'm very bad at this. Come on, somebody must know.
Yes, someone in the chat definitely should have an idea. And it is quite a famous number.
Somebody asked, by the way, while we're waiting for some guru to answer this question, whether these are production ready.
There are 2 options. So we can wait for someone with Google, and we can wait for someone with ChatGPT.
Oh yeah. Don says, is that phi?
What?
Phi, P-H-I. Phi? I don't know. Oh, Javier's on the chat. He says, This is about how much interest you got in a time. It's because it's split in time. If you had -1 and 2, then it will be 100%, maybe. Don't know. What
Okay,
does ChatGPT say?
so something is quite, your answer is quite complicated, but I hope you are right.
Yeah, ChatGPT, can you explain this as if we are 5 years old, please? Because we don't
Yeah,
understand finance.
okay, let me show you another thing. What will be if I will calculate this? And it returns almost the same number. I will do a little bit more magic. If I do this, I will get the same result. What is the name of this particular constant?
Someone was saying the golden ratio before.
Okay, who was that?
That was Don. Phi is the golden ratio. Himanshu as well.
Congratulations, Don. The answer is correct. I will not provide even more explanations because these functions are supposed to be boring. And yes, they are boring. And it doesn't matter that there is some golden ratio, etc. Another function, something for geometry data. Two new functions, polygons intersect Cartesian and polygons intersect spherical. This function just take two polygons and return 0 or 1. And we already used to have almost the same functions named polygons intersection Cartesian and polygons intersection spherical. They do almost the same, but actually calculate the intersecting polygon. The new function just returns 0 or 1. And yet another function for geometry named WKB. WKB is a binary format, standardized binary format for representing geometry data. There is one format named WKT and another format named WKB. The difference is that the first format is text and the second one is binary. And this binary format is typically used in external data formats, in geoanalytical systems, in data formats like Parquet. So now you can read and write this data easily. And this should be more interesting. New functions for conversion between color spaces. And specifically between the color space sRGB and another color space named OKLCH. What is the difference between sRGB and OKLCH? sRGB contains three components, red, green, and blue. And it is close to the representation of computer display. Most likely some old computer display, new computer displays have more complicated internals. But anyway, the signal typically is encoded as RGB, so it is natural as a hardware representation. But it is not suitable for arithmetic between colors. If you take two colors and calculate the average, it will not actually be the average because this color space is not linear. It is not perceptually uniform. If you take a color like 10% R, 10% G, and 10% B, and you take another color like 20% of all of this, it doesn't mean that the second color will be twice as light, twice as bright as the first color. It is just nonlinear. And another color space, OKLCH, is much better for arithmetic, for combination, blending, averaging colors. It is designed to be as linear and as perceptually uniform as possible. And it even contains some colors that are not yet representable by my display, by your display, but that are theoretically possible. And why do you think we need functions for color spaces inside ClickHouse? Where is ClickHouse and where is color science? Actually, we need these functions because ClickHouse is a great database for visualizations, especially massive visualizations in space for scientific data. And let me try to demonstrate you some examples. I will open one of my favorite websites, name it ADSB Exposed. And this website, if you did not see before, it contains visualizations of air traffic, airplanes. It contains like 150 billions of traces of airplanes, helicopters, gliders, all flying stuff collected over several years. And what it does, it allows you to run arbitrary query. And in this query, you just calculate colors, red, green, and blue, directly with SQL. And it will visualize these colors. And you can see that to calculate color red, we take the average. And my hypothesis is that this is slightly not right. It is slightly not right to do averaging in the RGB color space. Let's try to do some magic. And the magic will be, let me open it in another tab. What is the difference? I don't know which picture is better. Which is better, this or this? I don't know. But to get this picture, we do one trick. We calculate what's supposedly to be RG and B for every data point. Then we convert it to OKLCH color space. Then we do average inside this color space, inside perceptually uniform linear color space. And then we just convert the result back. So essentially, we do averaging in a different coordinate space. So there is a difference in the result, and we can see that here orange and red is less pronounced, and here it is more pronounced. I don't know, but after this explanation, I like this picture more. Now let's take a look at another picture. Here I have quite an interesting visualization where each color based on a hash of an airline. So KLM will be one color, British will be another color, Lufthansa will be yet another color, and American will be somewhere here. And let me apply the same trick. I will do the same calculation in a different color space.
I know what's happened to Alexei. Seems to have got disconnected. I guess we'll wait for him to come back. Let me have a look if we got any questions in the meantime.
Sorry.
You're back. Cool.
What is with sharing? Should I share again?
Yeah.
When did it interrupt?
You were sharing the analysis in a new color space
Okay.
against the KLM and other flights.
Okay, so we have two visualizations. One to the left, this one, and one to the right, this one. My question to Mark, which visualization you like more?
Okay, I can see it now. So wait, what's this? So that one or?
This is to the left, and this is to the right. Let me show you again. Visualization A or visualization B.
I think the first one I like better.
Okay, the first one is what we already had. The second one is using
Very pink.
functions. And you said it false. Okay, no problem. We don't need this new function then. But I would say that in this visualization, we have a better separation between colors. You can see orange traces, and you can see something in the background. And here we can see like magenta, pink traces and the same in the background. Okay, but anyway, looks like the difference is not clear, so let's move on. We have to move on because this visualizations make Zoom glitch a little bit. And probably this is why this function's worth it. Yet another feature, colorful brackets in ClickHouse Client. This is pretty simple and not boring at all, and easy to demonstrate. So let me show it to you. I will type select, and I will type a bunch of brackets. You can see all the brackets are gray, but if we will pair these brackets, what do you see? They are just became colorful and perfectly matching each one. That's amazing. Amazing feature, and I like it so much. Okay, yet another feature. Not so interesting, but quite sophisticated. A new data structure for compressed numeric vectors. This data structure is using bit slicing algorithm, bit slicing approach. Let's suppose we have a map from a number like an index in an array to the value. Something like at position 1, we will have value 10, at position 5, we will have value 11, and so on. And this map can be compressed by extracting, by splitting the values into separate bits, like the least significant bit, the second bit, and so on. Splitting these bits into different parts and compressing each part as a bitmap. Maybe it sounds quite complicated, but now we have this data structure that you can create using an aggregate function or using a regular function from a map explicitly, and we have a bunch of functions to do something with this data structure, to manipulate with this data structure. We can calculate the cardinality, we can sum all the values, get value at a position, or do point-wise operations like add vectors together, subtract, multiply, do comparisons, logical operations, and so on. And how does it come? We have these functions in ClickHouse. Because apparently it was a way to speed up metrics calculation for A/B testing in Tencent. And they contributed these functions to ClickHouse because supposedly they will be useful for everyone, including you. Let me provide you some example just to prove that these functions are for something. Let me try to improvise and create a few tables. I will create a table with metrics and a table with maybe it is impressions, maybe something else. Page impressions, I don't know. Just two tables with segment identifier and some value. I will insert a bunch of data into these tables, just about 100 millions of records. It should be quick. I'm inserting 100 millions of records of synthetic data with random numbers. Okay, one table is done. Here is another table. Let's wait just about 10 seconds. And we will play with this interesting data structure. Mark, did you understand what is data structure? What is this data structure?
I think you already know the answer to that question.
Yeah, it's because I'm not sure. It's better to show that rather than trying to explain. And I will create another table named metric BSI. And this table will contain this data structure, compressed numeric vector. Okay, it is created. And now I will aggregate data from the first table into this data structure and insert into destination table. Okay, the insertion is much faster. Actually not very much so, but it works so far. Let me see how it works. Maybe the calculation of this data structure actually takes significant time. Anyway, the subsequent calculations with this data structure should be accelerated. At least this is the promise of this function. But if I look at the top processes in my system, actually Zoom takes most of the CPU, and ClickHouse does not take a lot. But anyway, yeah, we have this data structure and it is trying to do something. Actually, I know what I will do. I will just go to my favorite server and run it here. It should be much faster, especially if I have any problems with my machine. Yeah, it is much faster. Okay, just 2 seconds. Yeah, my server is way more powerful than my machine. Here is another table with this data structure. And now let me finally show what is the point of this function. So the first, I will do a join query between my two tables. I will join by segment ID. something like a segment that was used for A/B testing. And I will apply some condition like here, offset between 2 and 5. And it is fast. It takes just half a second. But anyway, if I will do another query, which is way more complicated, and believe me or not, this query does the same join and the same condition, but using my new data structure. And guess what? Actually, it is not faster. I don't know why these functions exist. The join was faster, but this function is supposedly should optimize the query, but it doesn't optimize the query. So let's move on to the next feature.
I guess we have to say ClickHouse was just so fast already.
Yeah, because we optimized joins during this time. Okay, let's move on to boring security features. What about boring security features? The first security feature is separation between read and write permission for accessing external data. In previous version, if you want to grant access to S3 table function on URL or URL table function or file table function, you just grant access to it and the user get both reads and writes allowed. In 25.7, you can enable a configuration which will allow you to configure reads and writes separately. So, for example, you have a very security conscious customer, and this customer say, please forbid all the users writing to S3 because it makes the possibility of data exfiltration. But let's permit reading from S3 because it is generally useful. And now you can do it quite easy. Parameterized create user queries. It is very easy. The create user query can be parameterized. So you specify substitution in a query and you set the parameter from the outside. Let's move to performance improvements. How did we speed up ClickHouse server? The first one is speed up for group by queries. Group by queries are already fast in ClickHouse, but we made them even faster, like 30% faster, when a query only has one simple aggregate function count. If it is a query of this kind, it will invoke a specialized optimized code path, which can slash 10 milliseconds from a query runtime. So what was 42 milliseconds, now just 32 milliseconds. And I count every milliseconds of query runtime, so it is quite notable, at least for me. Asynchronous logging. It is quite easy and enabled by default. You can disable it, but you don't have to. It speeds up logging, and especially if you write to a slow file system, if you write to a terminal, and if your terminal is slow, then logging can slow down ClickHouse just a bit. And I don't like anything that slows down ClickHouse. So now logging is asynchronous. And if you do highly concurrent queries, short queries, it will give you more queries per second. Like in this example, this is quite a short query, capable of running 225 times a second. After enabling asynchronous logging, it runs 255 queries per second, just 30 queries per second more. And even more optimizations for joins. And actually, we have 4 different optimizations new optimizations for joins. Optimizations for full outer join and right outer join. Optimizations for joins with multiple OR conditions. Optimizations that bring inner join performance to be as fast as the performance of in operator. In operator is easier than join, but now join runs equally fast. At least if the in operator does not utilize indexes. This is another case. Better memory allocations. So joins in the new version are faster. If you have a lot of joins, just install the new version and you will see the benefits immediately. And about insert select queries. Now they are distributed by default. If you do insert select from a distributed table into another distributed table on the same cluster, or if you do insert select from a replicated table into another replicated table with parallel replicas, it will split the query pipeline across all the servers and run it in parallel. Until recently, you had to enable it manually. Now it is production ready and enabled by default. Okay, what about something interesting, something like headline features in the new release? And the most interesting is support for full-featured update statement with lightweight updates. The statement looks like in any other relational database management system, any other OLTP database. Update, set something where condition. And you can do a lot of stuff like change a column or even increment a counter. This is not the best way for incrementing a counter, but it will work and it will be fast. Let me explain how is it possible. This is supported for merge tree table family, for regular merge tree, replacing merge tree, and collapsing merge tree, for replicated tables and non-replicated tables. And obviously it is supported in ClickHouse Cloud as well. To enable this feature, you enable special columns in your merge tree table. One is named block number column and another is block offset column. And these columns will be used to implement lightweight updates. The performance of lightweight updates is similar to insert select with the same columns and conditions. So if you do update where, and if the where clause can use index, the update will also use index. And if you update just a couple of records, it will be a small insert, and it will also be fast. How is it possible? It is implemented with patch data parts, a new data part format containing references to the modified records with the modifications. Patch parts are easy to create during the update statements, and they are easy to apply during the select. Updates will be immediately visible by select queries. They are consistent, isolated, and so on. And first, let's compare the select performance with the presence of updates. If we do heavy mutation with full data rewrite, there is no overhead on select, so this is our baseline. If we do mutations on the fly, that we already have, that will calculate expressions on the fly without inserting any data, without modifying data, it is 2.5 times slower. because there is a high cost of calculating these expressions. With the new mechanism, lightweight updates, the difference in performance is just 20%. 20% is what does it take to apply patch parts on the fly on selects. And this is pretty good result. So it works like this. We join data parts with patches on the fly in parallel, using all the optimizations, using highly efficient hash tables with these block numbers and row numbers, and then process the query pipeline as usual. And now you can do updates as frequent as you can do inserts. And let me show it on the same, on this comparison. If we do heavy mutations with alter update, it is on average 23 times slower than lightweight updates. And lightweight updates take almost no time. So this is pretty nice. And as a bonus, you can also enable the same mechanism of patch data parts for deletes. Just set lightweight delete mode to lightweight update, and it will do the stuff. Okay, what is also really nice in the new release? Support for inserts into Iceberg. You already know that ClickHouse supports Iceberg, ClickHouse supports Delta Lake, ClickHouse even supports Hoodie. ClickHouse has support for all data catalogs, including REST, Glue, Unity, Hive Metastore, everything you can imagine. But until recently, this was only for reading. So you can attach an Iceberg table, you can read it, you can analyze your data from Databricks, from Snowflake, from everywhere. Now you can attach an Iceberg table and write to it. That's pretty easy. And let me quickly prove that it works. So here is my favorite server. And let me copy paste some queries. I will try it on my machine. However, there are some glitches on my machine, so let's take a look. Yeah, I have an Iceberg table from S3. Let me select from it. Yeah, it works. And it is pretty fast. And here is just a single record. Now let me try inserting. It works. And the data is definitely inserted. No surprises. Everything works. Okay, what else? We have even more feature for Iceberg. Full support for schema evaluation with complex data types. Reading tables with positional deletes. So if someone deleted some records from the table, ClickHouse will recognize it and process these deletes. Compressed metadata JSON files, because metadata JSON can grow quite big and then it will have to be compressed. Reading renamed columns by column identifiers, so everything for compatibility. And now it has full support for Databricks managed tables. So you can create a table inside Databricks, and then using Iceberg REST compatible endpoint to access these tables. Let me not show you how it works, because it works, and it is not surprising how well it works. Let's take a look at what we have as a bonus. And we have something about AI from our guest presenter. So welcome guest presenter, Kaushik. Now to you.
Yep, thanks, Alexei. It's hard to follow the changes like lightweight updates and Iceberg, but we'll see what we can show here. Let me quickly share my screen. Cool. Hopefully all of you can see this. So as of the latest release 25.7, we have a new feature by default in ClickHouse, right? So let me demo it without any further ado. So you run your standard ClickHouse curl command, which gets you the binary. I already have it, so I'll open it. And let's launch ClickHouse local. So this is something that we are calling ClickHouse Client Agent. It helps you run or write queries in natural text using the modern LLMs, right? The way you invoke it is fairly straightforward. So you put two question mark symbols and say create a table or GitHub. This can be any natural language text here, right? Once you run this, this is almost zero config. So it asks you, hey, it recognizes that there's an Anthropic API key in your environment. It asks you, can I use it to generate SQL? It works with OpenAI API key as well. And we can also configure it based on several configuration parameters that are in the docs. I'll come to that a little later. No, we click yes. So the interesting thing here is that we equip this agent with a bunch of tools, and it can use those tools to do schema discovery and inspect the table definitions and generate a query, which is very reasonable. So let's see, it seems to have created a table called GitHub events. Let's run this. Yep, it seems to have worked. There is a little bit of non-determinism to this because of the LLM, but most of the time it seems to work with at least the Claude models that I've been trying out. And now let's do something a little more fun. Let's insert 3 rows into GH events. I'm not going to call it GitHub events. Let's see if it's able to identify. Yep, let's run this. And as you can see, it's able to insert some sample data here. Let's go into a little more interesting use case. So I set up a ClickHouse Cloud instance. This is just connecting to that. So I'll connect to the ClickHouse Cloud instance. And my history, there should be some interesting queries. Yeah, so I have this NOAA dataset. It's there, and I want to get the lowest 5 temperature recordings here, right? I could, see the table schema and write the query, but we want to be lazy. Just do this. So let's see if this works. As you can see, it does this in Celsius and Fahrenheit, and let's run the query and see if it works. This is a very low configuration machine that I provisioned just for the demo, so it might take a little while. Yeah, but you can see that it did run the query and give you some interesting results here, and obviously works for more complex queries as well. But I want to go into a little bit more detail about how this feature was implemented to give you a behind the scenes view of things. So let me share that part of the screen. Okay, hope you can see my presentation here. So we're calling this the ClickHouse Client Agent, right? It's released by default. It's 25.7. You can see the docs here, and you can please share the feedback regarding this feature as well. So one thing that we noticed while we started working on this feature is that to effectively support a lot of use cases and a lot of variance in how people use these various LLM tools, we have to provide a support for OpenAI, Anthropic, Gemini, OpenRouter, all the other models out there, and adding all that features into the ClickHouse codebase could be one way to do this, or one other way could be to open source that piece separately so that all the C++ developers can start using, like an abstraction that supports communicating with any of these providers. So we launched AI SDK CPP. So feel free to try it out and give it a shot. It provides like a single interface to query all the model providers, right? It's inspired by a bunch of other tools out there like Vercel SDK and LightLLM and OpenRouter, right? It does a bunch of things by default for error handling and controllable retries. One might think, isn't there already some degree of uniformity between all the LLMs out there? Not really. If you see, all the various providers have very different ways of doing things. For example, in OpenAI, you can pass the system prompt once, whereas in Anthropic, you have to pass it over and over again. Tool calling semantics are very, very different across all these providers as well, along with the responses. So having one nice way in which you can integrate this feature into ClickHouse just made sense. And we think it will be really useful for everybody else out there too. Another thing that's a key part of this, the schema discovery piece that you've kind of seen, is that we equip the ClickHouse Client Agent with a bunch of tools, right? In our context, we gave it list databases, list tables in a database, get schema for a table. In the future, we are thinking about exposing get query history and sample table as well. And these would essentially enhance the kind of queries that the LLM can generate for you. And yeah, like we do want to consider doing these in the future. An example of how writing a tool call would look like, this is just for developers more than anything else. If you want to contribute a tool call to ClickHouse, this would be useful for you. So it's very simple. We write the query and we essentially get back the JSON value as a result, and the LLM can then infer these. So there was quite a bit of thought that went into the UX around this feature, right? We wanted to make it as zero config as possible. So we infer from the environment variables like we told you, but we have knobs to configure every single thing that we expose to this agent, right? Like the prompt, the temperature, the kind of system prompt that is given, etc. There's also a decision to show the thinking and the detailed response flow. I think this is a very useful pattern that everybody else is out doing too, but it gives you insight into what the model is thinking and doing. So let's say it does not generate the right query for your use case, and it does something that's kind of bad. Looking at these traces, you're able to modify your prompt to kind of guide and steer the model to what you want to do. The third thing is that right now we place the query into the buffer versus executing the query directly, so that it gives you a chance to like tweak the query, and if there's something that's absolutely wrong, like dropping the whole database or truncating, you can correct it before running it. So the other piece that I wanted to touch upon briefly was the prompt itself. So in prompting, there's generally zero-shot prompting versus few-shot prompting. We ended up going with few-shot prompting, where we describe the flow we want the assistant to take, right? Like including the tool calls, so that this led to much better query generation. We also asked it to give responses in XML versus JSON. Anecdotally, this has given us an easier way to parse things out. There's still sometimes a markdown problem where the model gives you like 3 backticks and SQL, but hey, we can't get to perfection on day 0. The last thing I wanted to briefly touch upon was the future roadmap. As I said earlier, we are thinking about adding 2 to 3 selective tools, because too many tools means a confused LLM. The second piece that a lot of my colleagues in ClickHouse asked me was, I don't want it to just place in the buffer. I want it to automatically execute the queries, do some research, and go ahead. So this is typically called the YOLO mode, where you give your prompt, you come back 6 hours later, and it executes, and you get to see the result. So there's some consideration going on, and like maybe we should allow this kind of a mode too. And some random thoughts from my side are, like it'd be great to have some kind of an autocomplete be shipped by default. So fine tuning some of the smaller models, ghost text autocompletion for SQL would be something really cool as well. Yeah, I'm really excited for everybody to try out this feature and share some feedback, and I hope it improves much more in the future. Thank you so much, and thanks, Alexei, for this opportunity.
Thank you. Really interesting. By the way, what is the best LLM for ClickHouse?
So far, it's been Claude models like Claude Sonnet 4 and Opus 4 have been really, really amazing. Don't use the Mistral models yet. They're not generating good queries for ClickHouse. But yeah, the Claude models have been amazing.
What about local LLMs?
Local LLMs, yes, the new Qwen 3, I think it's really, really good. I've also been playing around with, trying to fine tune some of these. So like the local models that I train are even better, but we'll get to that in the future release, Alexei.
Yeah, looking forward for this. Okay, what else? What about integrations? There are a lot of updates for ClickPipes. Now it supports logging into system tables. Confluent Cloud has a full-featured managed ClickHouse connector out of the box. Kafka Connect now supports the new JSON data type. Airbyte has a new destination. And we have MySQL CDC, change data capture, in public beta in ClickHouse Cloud. And if you want to use MySQL CDC to synchronize data from your MySQL database into a more modern database, ClickHouse, just push this button on our website and you will sign up for our public beta. About meetups, we have quite a lot in all around the world. From Tokyo, Jakarta, Seoul, Manila, to Tel Aviv and Dubai. And we have a lot of interesting content on our blog, on our website, including customer stories from OpenAI, Anthropic, Tesla, about LLM observability, agentic analytics, our MCP server, so AI, and again AI. But also we have an article with deep dive about how we implemented lightweight updates, fast updates in ClickHouse. And this is probably one of a few missing parts that were in ClickHouse, and now ClickHouse is even more complete with lightweight updates. Now we probably have time for one question or not. Mark, it's up to you.
Yeah, we can do our one question. Some people were asking about a llama. I'm pretty sure you can do that already on the AI thing if you configure the URL. So the only question we have is from Stefan, which is maybe you understand. Fast maps, are they coming?
Maybe you meant sharded maps. Yeah, it is in the roadmap. Interesting feature. One of the next steps. Currently, it is not in progress. It is on pause in favor of other features. And by the way, the engineer who implemented lightweight updates is also the author of sharded maps. So there is a chance, maybe we will choose to finish sharded maps next. Maybe we will choose something else, like unique key constraint or absurd statement. What do you want more, sharded maps or unique key constraint? But we will decide.
Stefan, you got to tell us. Another question. What are there any downsides to using the lightweight updates?
There is slight increase in table size. Typically, it is negligible because these additional columns with block numbers, they are very compressible. And if you do updates, you will have just a slight overhead on selects, like 20%, as I shown. By the way, if you don't want this overhead, you can ask for reading non-updated data. There is an option. So almost no downsides. Sometimes lightweight updates are just less efficient than other methods of updating, because you can do lightweight updates as frequent, as quick as you can do similar insert selects. But sometimes you can do something smart and still get away with replacing merge tree or dictionaries. The old techniques, just keep them in your disposal. Maybe they are still useful.
Cool. Then we got one more. Arno was asking about progress on the new Parquet reader.
Oh, it is very close to be merged. I hope but I don't guarantee that it will be in the next release 25.8. So add it to your calendar. It will be at the end of August. The date is already available. It should be already on our website. I hope it will be merged, but it depends. It depends on the number, on the quality testing, the number of found issues.
Cool. I think that's it. I think we've done all the questions. Thank you everybody for coming. I get Kaushik's gone, but thanks Kaushik for your cool presentation. Everybody give a try to the AI and let us know how you get on.
If you are not bored with AI, try it. It works.
And if you are bored with AI, try it. It works. You won't have to write base SQL anymore. Fundamentally, try it out. Try 25.7. Tell us what's amazing. Tell us what's not. Hit us up on X, on LinkedIn, on Blue Sky, on Slack, clickhouse.com/Slack. You can join our Slack community. And yeah, Stefan says, as someone who just typed a bunch on X, tweeting about the things that we just did, this was as great as always. Thank you so much, everyone, for being here. Share it with your friends. Use ClickHouse. Tell us where it's amazing. We look forward to seeing you next time.